Okay, so in this lecture, we are going to discuss exercise get equipped to JEE Advanced of gaseous state. We are going to solve question number 1. So question number 1 is the mole fraction of helium is given in gaseous mixture of helium and methane. If the mole fraction of helium is 0.4, mole fraction of CH4 is nothing but 1 minus 0.4, that is 0.6. Okay. If both gases are diffusing through a constant area of orifice of the container, so that means एक container में ये है और इससे ये बाहर निकल रही हैं दोनों gases, then what will be the percentage composition by volume? It means you have to calculate volume of CH4 divided by total volume, that is volume fraction, into 100, that is percentage volume of CH4 gas diffusing out initially. So you have to find this now. We know the mole fraction. We say, let's say if total number of moles are equals to 1, total number of moles are 1, so the mole fraction is nothing but number of moles. So we can say कि inside 0.4 moles है और ये 0.6 है, right? If total moles is equals to 1, then these are the number of moles of helium and CH4. Now at what rate they are going to effuse out? So we are going to solve. Rate of helium divided by rate of methane is nothing but moles of helium inside divided by moles of methane. Because moles are not same, partial pressure is going to be different, so we have to write this formula, divided by mass of methane divided by mass of helium. So you can write the values. So 0.4, 0.6, root 16 by 4. If you are going to cut, this is 4. So 0.4, 4 ka root 2 times 2, 0.6. So this is going to be 4 by 3. Now, ये है rate of effusion, है ना? ये तो जो भी ये गैस निकल रही होंगी उसमें 4, let's say 4 moles or 4 times volume helium का होगा और 3 times volume methane का होगा, right? So that's it. आपको क्या निकालना है? Let's say rate of fusion of helium divided by rate of CH4 is nothing but you can say V out, right, by dt of helium divided by V out of by dt of methane dt of methane. Okay, so that is nothing but 4 by 3. So let's say if 3 liter is going to be methane is going to effuse out and 4 liters of helium is going to effuse out, then percentage by volume क्या हो जाएगा? Volume of methane is 3. Total volume is going to be 7. 3 plus 4, 7 into 100. So we'll be getting 300 by 7 and approximately 43%. So that is going to be your answer. Okay, now question number 2 does not represent isobar given by Charles law. So you just have to check Charles law over here. You can directly see over here, it is degrees Celsius. So it is not going to be like from origin, right? 0 degrees Celsius means 73 Kelvin. So this is going to be wrong. This is the wrong graph. Question number 3. Two gaseous samples are separated by conducting frictionless piston. Conducting means over here the temperature is going to be same because it is a conducting, so energy can pass on as shown in the figure. If the piston is in equilibrium in the position shows. If this is in equilibrium, that means the temperature is same and the pressure is also same because it is at equilibrium position, it is not moving. So whatever the pressure over here is, similar pressure is over here. Which of the following statement is not true? So they are asking which of the following statement is not true. Okay, A is equals to TB, correct? A is equals to PB, this is also correct. NB equals to 3 Na. So we have to see. It is saying L and it is saying 3L, right? So anyway, they have also said कि यहाँ पे जो volume है वो 3 times है. So if temperature and pressure both are same, the volume is proportional to number of moles. So what will happen? Volume is 12 times, then the moles is also going to be 3 times. It is also correct. So all these are options are correct. Which one is this? This is total kinetic energy of gas A equals to total kinetic energy depends on temperature 3/2 RT per mole. It depends on temperature. Temperature is same, then it should be same. So okay, this is wrong. Our answer is D. Question number 4. What percentage of a sample of nitrogen must be allowed to escape? Its temperature, pressure, and volume are to be changed as given. Okay, so this is initial state, and this is final state. And let's say the number of moles initially is N. N is nothing but P by RT. So we can write P value is 3 and V value is 1.65. It's going to be 273 degrees Celsius. So 546 R 546. So this is N value. Now what is let's say number of moles over here? So N dash, let's say it is going to be P is nothing but 0.75, B is nothing but 0.55, and P is nothing but 273 R. Let's say we want to build a relationship between N and N dash. So what we can write is we can divide. So that is nothing but 0.75 into 0.55 divided by 273 R, and then 3 into 1.65 divided by 546 R. Okay, so this is going to cut 2 times. This is going to cut 4 times. Going to cut 3 times. So 2 is going to go up. 3 into 4 is 12. So that is 1 by 6. So N dash is nothing but 1 by 6 N. It means how many moles are remaining? 1 by 6 of initial moles are remaining. What they are asking? What percentage of sample must be allowed to escape? So they are saying how many moles should be escaping. Okay. So if we are saying 100% moles are initially present, then 100 into 1 by 6%, that means 60.67% is present right now. So how many have been escaped? 83.33%. Again, they have given the initial state and final state. They have calculated what is initial number of moles. You have calculated what is final number of moles. And then what you have done is you have find the relation over here. So the relation we are able to find is number of moles are going to be 1 by 6 of initial number of moles. What is the percentage? So you can say 16.67% is remaining. So 83.33% have been, let's say, escaped. Okay. Now there is another question, question number 5. In the above figure, mercury column of 10 centimeter each are tagged. Okay. So this is column, this is P gas. Okay. Between gas column of 10 centimeter each. Okay, this is also gas. If PATM is 75 centimeter of Hg, then the pressure in the topmost column is okay. So we'll see this graph over here. This diagram. Question number 5. Okay. So they are saying there is a container and there is a tube like this. They're having gas over here and 10 centimeter mercury column, and let's say gas, then 10 centimeter mercury column, and then let's say gas. So let's say okay, 10 centimeter gas. So this it is like this. Okay, this is 10 centimeter. This is 10 centimeter, The pressure at this point, which is atm, that is 75 centimeter. So now we have to understand what is the pressure over here. Okay. First we have to see that if 75 centimeter is over here, then at this point is also 75. Since the pressure and at the gas is always same, so at any wall, at this point is also 75. There is a mercury. Whatever is the pressure over here, let's say this is the point P1, this is the point P2. So P1 will be equals to P2 plus 10 centimeter of Hg. Because this 10 centimeter of mercury's weight is going to be downward direction, right? So P2 plus 10 is going to be P1. So P1 is 75. P2 is nothing but 75 minus 10, that is 60. The same is going to be over here in, that's a gas. At all wall pressure is same, so over here is also 65. The 10 is over here. So at this point, let's say P3, we are going to say P3 plus 10 is nothing but 65. So P3 plus 10 is nothing but 65. So P3 is nothing but 55 mm. So you are asking what is the pressure over here? That is 55. Question number 6. In the quantitative determination of nitrogen, N2 is liberated from 0.42 gram of sample of organic compound was collected over water. Okay. So you can imagine some gases has been collected over water. This is water. Okay. And this is the gas N2. Right. If the volume of N2 was 100 by 11 ml at a total pressure of 860 mm of Hg and 250 Kelvin. So they have given volume, they have given pressure, they have given temperature. They are asking percentage by mass of nitrogen in the organic compound. Okay. So now you know P, V, and T, so you can calculate number of moles. So let's solve. The pressure was 860 mm of Hg, but that is nothing but moist, because of moisture. So that is Pn2 plus tension. Right, this is P moist. Aqueous tension is 24 mmHg. So Pn2, pressure due to N2 is nothing but 860 minus 24, that is 836 mmHg, and you can convert into ATM. So that is 836 divided by 760, which is 760, 76, 1.180. Okay, the pressure due to nitrogen is 1.1, temperature 250, and volume is given in ml, so you have to convert into liter. Now with this help you can calculate number of moles. So number of moles is nothing but V by RT. So P is nothing but 1.1 atm, P is nothing but 100 by 11 into 10 to the minus 3 in liters divided by 250 R. Okay, so we can solve. This is going to cut over here and say again. So this is 10 to the minus 2, you know, 10 or here 10 to the minus 3, 10 to the minus 2, 250 R. So these are the number of moles. Now, okay, number of moles, you know, then you can calculate. They have given R value also 0.08. So you want to consider this value only for this question. Okay, 250 R, right? So we can solve this value. It is nothing but 10 to the minus 2, 250 into 0.08. Okay, so 250 into 8 is 2020. So you can write that is 10 to the minus 2 divided by 2020. Okay. These are the number of moles. Okay, so when we calculate mass, moles we know, then mass is nothing but mass of N2. That is going to be 10 to the minus 228 into 3. And these are number of moles into molar mass 28. So we can say 1.4. 1.4 into 10 to the power minus 2. Okay, this is mass in gram. Okay. What is they are saying? Okay, 0.42 gram is the sample. So percentage we have to calculate. Okay. Mass of nitrogen we know. Now this mass is present in sample, let's say 0.4 gram organic sample. So percentage nitrogen is nothing but mass of nitrogen divided by mass of organic compound into 100. That is 1.4 into 10 to the power minus 2 into 100 divided by 0.42. Okay. So that's it. ये कट गया 0.42. So you can say 14 by 4.2, 10 by 3. So percentage is nothing but 10 by 3. Number 7. 1 mole of N2O4 at 300 Kelvin is kept in a closed container under 1 atm. Okay. This is the pressure is given 1 atm. Moles are given and 300 Kelvin is given. Okay. It is heated to 600 Kelvin when 20% mass of N2O4 decomposes to NO2. Okay. 20% of mass मतलब कितना हुआ? 20% of moles. Yeah. Right? जितना भी एक मोल था, मोल के करस्पॉन्डिंग जो भी मास था उसका 20%, एक मोल का 20% डिकम्पोज हो गया. This reaction would have been N2O4 is giving NO2 2 times NO2. शुरुआत में 1 मोल है, ये 0 है. आफ्टर द रिएक्शन 20%, इसका 20% 0.2. ठीक है. बट अगर इसका x मोल रिएक्ट करेगा, x मोल डिसोसिएट होगा, बचेगा कितना? 1 minus x. इसके 1 मोल से 2 मोल बनता है तो x मोल से 2x मोल बनेगा. So now we can write the value of x is 0.2. 1 minus 0.2, ये हो गया 2 into 0.2. 0.8 and this is 0.2. Total moles कितने हो गए? Total moles of gas is nothing but 0.8 to 0.4, that is 1. Okay. After that, let's say this composition 1.2 moles are there. They are asking resultant pressure is. Okay. So number of moles have been changed, temperature has been changed, the volume has not changed, closed container hai, right? So we can write V is nothing but nRT by P. We are going to solve this part. Volume has remained same initially and finally. Moles has been changed, temperature has been changed, and pressure has also been changed. So we'll see. That is 300, 1 mole, okay, 1 atm. 1 mole, 300, 1 atm is equals to 1.2 moles are 600, and we have to calculate P. We don't know what is final pressure. R से R कट गया, 300 से 2 times, so P is nothing but 2.4 atm. Okay, next question. Definite amount of gaseous hydrocarbon having carbon atoms less than 5. Okay, तो कुछ अमाउंट लिया है हमने और ये हाइड्रोकार्बन है, was burned with a sufficient amount of O2. Okay, मतलब सारी की सारी O2 will react. All the O2 is going to be consumed. The volume of all reactants were 600 ml. Okay. After the explosion, the volume of products was 700 ml. ठीक है, तो जितना अच्छा यहाँ पे ये गैस है, राइट, वाटर भी गैस में लिया. Under the similar condition, the molecular formula of this compound is. ठीक है, इसको करने के तरीके एक तो ये हो सकता है कि we are going to write combustion reaction CXHY X plus y by 4 O2 gives XCO2 plus y by 2 H2. Now what they are saying is, let's say stoichiometric coefficient is 1, x plus y by 4, x and y by 2. This is also considered as gas. This is also considered as gas. These are the stoichiometric coefficient. So one is saying कि ये दोनों का वॉल्यूम 600 ml है और इन दोनों का वॉल्यूम 700 ml है, right? So what you can do is you can say कि let's say a ml अगर रिएक्ट कर रहे होंगे तो x plus y by 4 a is going to be, you know, this and this is going to be 600. So you can write how many ml are going to form. xa ml is going to form, y by 2a is going to form. So you can also write reaction x plus y by 2 into a is 700. So this is a one equation you can solve, but obviously this is little bit lengthy. Solve, you have to cut and then need to, let's say, more time. So what we can do is we can check the option. Okay, let's try to, let's say, C. So we will start with C3H8. So C3H8 plus this is 3 and 4, like y by 4, 5 O2 is going to give 3 CO2 plus 4 H2. तो ओके, अगर इसका 1 होगा तो इसका 5 होगा, 3 4. दिस मेक्स सेंस. 1 plus 5 6. 6 से कितना बन रहा है 7. 600 से कितना बनेगा 700. ओके, सो दिस कुड बी योर आंसर. You can cross check all other options. C3H6 let's say. So C3H6 में तो आपको पता ही है कि ये C3H6, then it is going to be 4.5 O2, 3 O2, 3 CO2 plus 3 H2O. So that's going to be 1 plus 4.5 gives 3 plus 3. So okay, this will not come. And similarly, you just have to check other options, right? These are not going to come. So your answer is A. Number 9. A spherical air bubble is rising from depth of lake where pressure is P atm. Okay, तो एक लेक है और इसके बिल्कुल नीचे यहाँ पे प्रेशर P atm, right? And the temperature is T Kelvin. The percentage increase in radius. Radius में percentage increase पूछ रहे हैं. Spherical bubble है ये. Okay. When it comes to free surface, let's say जब ये top पे पहुंच जाता है तो क्या होगा? And assume the temperature and surface at the respectively P by 4 and 2T. Okay. So pressure is changing, temperature is changing, volume is also changing. So what is remain constant? Constant. जो उसके bubble के अंदर air है वो constant रहेगी. That is number of moles are going to constant. So PV equals to nRT से हम लिख सकते हैं N is equals to, NR is equals to PV by T. This is going to be constant. Just solve. So we can write question number 9. T1 V1 by T1 is equals to T2 V2 by T2. Right? Pressure is nothing but T initially. Let's say volume is V. Temperature is T. Next time pressure is P by 4, right? P by 4 2P. So P by 4, V, let's say V2 हमें निकालना है and 2P. Okay, you can cut. Let's V cut कर लिया. So this is nothing but V is equals to V2 by 4 is going to go down 8. V2 is nothing but 8V. तो एक ये वॉल्यूम में रिलेशन मिल गया, बट यू नीड टू फाइंड रिलेशन इन रेडियस. सो वी विल राइट 4/3 pi r2 whole cube, nothing but 8 into 4/3 pi r1 whole cube. 4/3 cut. r2 का whole cube is nothing but 8 times r1 का whole cube. So r2 is nothing but 2r1. So radius double हो गई. What they are saying? Okay. The percentage increase they are saying. So percentage increase is nothing but increase, nothing but R2 minus R1 divided by R1 into 100. R2 की value 2R1 है. 2R1 minus R1 by R1 into 100. So that is, है ना, ये आ जाएगा R1 by R1 100%. Your answer is 100% has increased. Question number 10. Excess F2 reacts with 150 degree. Excess में है 1 atm pressure with Br2 to give a compound this. Okay. 423 ml of Br2 at the same temperature and pressure produce 2.2 gram of BRFN. What is N? Okay. Okay, 150 degree. 150 degree means 423 Kelvin. पहले reaction लिख लेते हैं. What is the reaction here? Br2 plus F2 is going to form BRFN. Okay. Just see the stoichiometry. We can write 2 over here and N over here. Okay. So stoichiometry is 1 and 423 ml of Br2 at the same temperature. तो अगर if you are going to see this is excess, इसके 1 मोल से 2 मोल बन रहे हैं, right? इसके 1 ml से 2 ml बनेंगे, 423 ml से 826 ml बनेंगे. Now we know the volume, we know the reaction, let's say condition, because condition पे हो रही है temperature, pressure, ठीक है. So what we have, we can say number of moles हमें मिल जाएंगे, and in those number of moles we know the pressure, we know the mass. Okay, so let's see. Pressure is 1 atm, 826 by 1000 into V. ये लिखा हुआ है. P into V equals to nRT. Right, so N we don't know, R and T. R is 0.081 and T is 423 Kelvin. Okay, 423 से कट जाएगा ये 2 times. Okay, and N is nothing but 2 divided by, अच्छा ये इधर जाएगा, ये जाएगा 82.1. This is going to, so this is number of moles. इसका mass दे रखा है ना. You know, you need to know what is. Okay. These are number of moles. तो आपको ये पता लगाना है यहाँ पे कितने times N होगा. अच्छा, do not get confused by this N and this N. This is number of moles. This is just stoichiometry, right? So the N value is number of moles is this. What is number of moles? Given mass divided by molar. So given mass 4.2, molar mass we have to solve. So molar mass is 82.1 into 4.2 divided by 2. Okay, so this is going to be 2.1. Okay, now I just need to multiply 21 into 2, right? Or you can say 82. 82 into 2, that is 164, and so 8. 120. We just multiply 8, 21, 21. That's 21, 1, 2, 21, 2, 42, or 2, 44, 4, 8. 21 into 8, 168, or 4, 168, or 4, 170. So this is going to be close to 172.4. Okay, molar mass. Now what they are saying is, okay, bromine is 80. So what is molar mass over here? 80 plus 19N is equals to 172.4. So N is equals to, इससे से 80 subtract करेंगे, then it is going to be 92.4 divided by 19. It is close to 5. Okay, this is your answer, C. Okay, again in this question what we need to do is, ये bromine और fluorine आपस में react करके BRFN बना रहे हैं. So you need to say कि अगर 423 ml bromine लेंगे गैस में, then it is going to form 826 ml BRFN. Just have to calculate what is number of moles. ठीक है, number of moles जैसे calculate किए उससे आप mass पता है तो you can calculate molar mass, and then you can say what is going to be N over here. Rubbing this. ठीक है, ये सो हटा रहा हूँ मैं. In this question, the system shown in diagram is at equilibrium at 27 degrees Celsius. Okay. The volume of the valve is 150 ml. So okay, this is 150 ml. At this temperature, the vapor pressure of water is 28 millimeter of mercury. Okay, pressure due to water is 28 mm. If the bulb contains 0.01 moles of O2, okay, so जिसमें 0.01 mole of O2 है, volume of liquid water is approximately, okay. इसका मतलब क्या है? देखो, ये जो बल्ब है, ये इसका टोटल वॉल्यूम 150 है. जो भी वॉल्यूम ऑक्सीजन का आएगा, है ना, जो भी वॉल्यूम ऑक्सीजन का आएगा, उसको अगर 150 में से सब्ट्रैक्ट कर देंगे तो बाकी वॉल्यूम ऑफ वाटर मिल जाएगा, लिक्विड वाटर. वी हैव टू कैलकुलेट व्हाट इज द वॉल्यूम ऑफ O2. कितना वॉल्यूम O2 ने ऑक्यूपाई किया है, कितना अवेलेबल है ऑक्सीजन के लिए. कैसे करेंगे? मोल्स पता है, टेम्परेचर पता है, प्रेशर देखेंगे. तो अब यहाँ पे इन्होंने वैक्यूम दे रखा है, तो यहाँ प्रेशर 0. इस पॉइंट पे प्रेशर कितना हो गया? 160 mmHg. जितना यहाँ पे उतना यहाँ पे होगा 160 mmHg. ठीक है, तो कितना है टोटल प्रेशर होगा? The moist is nothing but the O2 plus 28 is 161. Pressure due to O2 is going to be 133 mmHg. Okay. प्रेशर मिल गया. वॉल्यूम निकालना है, राइट? दे रखा है. ओके, चलो वॉल्यूम निकालते हैं. 133 डिवाइड बाय 760 वॉल्यूम इन लीटर निकल जाएगा. ये जैसे ml लिखना है तो 1000 और लिख लो यहाँ पे. ठीक है, अब वॉल्यूम ml में निकलेगा, राइट? तो पहले लीटर में निकाल लेते हैं. कन्वर्ट लीटर, वॉल्यूम लीटर. ये लिखा हुआ है कितना? 0.001. so that is 10 to the minus 3. 300. R की वैल्यू 0.081 0.0821 into 300. We are going to remember this is 24.63. Volume is nothing but 10 to the minus 3, 760 into 4.63 divide by 133. We are going to solve it. इसको solve करो. ये 0.76 हो जाएगा और इसका इससे मल्टीप्लाई करेंगे. इसको एक बार सॉल्व करो तो आई थिंक ये 0.14 लीटर आएगा. वॉल्यूम इज गोइंग टू बी 140 ml. और देन यू कैन से कि कितना वॉल्यूम अवेलेबल हो गया. 150 minus 140 that is 10 ml. Okay, so this is question number 11. In the following figure, when two stopcocks are opened, stopcocks means ये, the total pressure inside the flask will be. इनको ओपन करेंगे तो ये गैसेस सब मिक्स हो जाएंगे और सब में प्रेशर बराबर हो जाएगा. ओके, क्या होगा जब ऐसा होगा? तो नंबर ऑफ मोल्स ऐड हो जाएंगे. हाउ मेनी मोल्स आर हियर? यू कैन सी प्रेशर यहाँ लिखा है, वॉल्यूम यहाँ लिखा है, 2.13 into 1.5 RT. These are number of moles. PB by RT plus 1 into 0.86 by RT plus 1.15 into 2 by RT. ये क्या हो गया? मोल्स ऑफ CO2 प्लस मोल्स ऑफ H2 प्लस मोल्स ऑफ आर्गन. ये टोटल मोल्स हो गए एंड टोटल. Now what is volume total? V total is nothing but 1.5 and 2.5 liter. बस अब प्रेशर निकालना है. So P total is nothing but and total RT by V total. बस ये सब ऐड कर लो आप. ठीक है, 2.13 into 1.5, 15.3, 45, 4, 15, 4, 9, 1, 15, 30, 30 और 1, 31. आ जाएगा 3.195. Okay, this is 0.86. Okay, and this is going to be 2.3. तो इसको 3.2 ले लेते हैं. Okay, 3.2 and 2.3, that is 3.5, 5.5 and 5.5 and 0.86, 6.36. ये आ गया 6.36 by RT into RT divided by 4.5. RT cut 4.5 से इसको कट करो 2.5 4.5 आ गया 1.86 1.4. Okay, so A is your answer. Question number 13. Determine the molar mass of a liquid. This small sample of liquid was vaporized in a glass vessel with a hole opening. Okay. Volume of vessel was this. And the liquid was completely vaporized in boiling water bath at 100 degree Celsius. तो ये कह रहे हैं कि ये कंटेनर है, इसमें मान लो कुछ लिक्विड रखा होगा और एक वाटर बाथ है जो कि 100 डिग्री सेल्सियस पे है. इसको हीट करें और इसकी वेपर बन रही है और ये कंप्लीट वेपर बन गई. ठीक है, कुछ नहीं बचा इसमें, है ना, कंप्लीटली वेपराइज्ड. ये जो वॉल्यूम ऑफ कंटेनर हो जाएगा वो वॉल्यूम ऑफ वेपर हो जाएगा, वॉल्यूम ऑफ गैस. एटमॉस्फेयर प्रेशर वाज दैट डे वाज 743 और अच्छा, अगर ये जैसे वेपर कन्वर्ट हो रहा है, राइट, तो पूरा का पूरा अगर ये वेपर कन्वर्ट हो जा रहा है इसका मतलब ये बॉइलिंग हो गया इसका, राइट. एंड एट दैट लेट्स से टेम्परेचर जो पी गैस होगा वो पी एटमॉस्फेयर के बराबर होगा. गैस इज नथिंग बट पी एटमॉस्फेयर, है ना, बॉइलिंग पे पी गैस इज नथिंग बट पी. आफ्टर द वेपर वाज कूल डाउन. ओके, तो कूल डाउन में इन्होंने कहा इट हैज कंडेंस्ड बैक टू ए लिक्विड एंड इट हैज वेट दे रखा है. तो तुम्हें पी गैस पता चल गया, पी एटीएम के बराबर है. टेम्परेचर यहाँ पता चल गया, दैट इज 100, दैट इज 373 केल्विन. वॉल्यूम पता है 115.3 ml है. सो व्हाट यू कैन कैलकुलेट इज नंबर ऑफ मोल्स. If you are able to calculate number of moles, you can calculate molar mass because mass is given. So that's what we have to do. Number 13. Volume is given 115.3 ml. Pressure is given as 743 torr, so 760, and temperature is 373 Kelvin. So let's say number of moles is nothing but V by RT 115.3 divided by 1000 into 743 divided by 760 divided by RT 0.0821 into 373. If you have to solve this, so what is going to be, let's say, value over here? We can say 115.3 into 743 divided by, let's say this is going to be 10 to the minus 3 over here. 760, 0.081 and 373. Solve it. 115. This will come close to 3.68 into 10 to the minus 3 moles. Okay. Now you can say what is molar mass. So 3.68 into 10 to the minus 3 is equals to 0.443. Let's say I'm writing 0.443. 0.443 divided by molar mass. So molar mass is nothing but 0.443 divided by 3.68 into 1000. So 443 divided by 3.68. So if you are going to, let us solve to 3 times. Okay, just see the option. 120 times 360. Okay, so this is going to be our answer. Let's cross check it. Yes, this is our answer. Okay, question number 14. For two gases A and B, the molecular weight MA and MB. Okay, It is observed that at a certain temperature T, दोनों एक ही टेम्परेचर पे हैं T पे, okay. Mean speed of A is equals to mean speed. Mean speed means average speed is equals to root mean square speed of B. Okay, so U average of A is nothing but U RMS of B. This is nothing but 8 RTY pi MA is equals to root 3 RTY pi, sorry, root 3 RTY MB. So both are equal, so you can say temperature is same. You can establish a relation between MA and NB. देख लेते हैं. हो जाएगा 8 RTY by MA is equals to 3 RT by MB. RT cut. So MB is equals to ये इधर गया 3 MA 3 pi MA by MA by 8. Yeah. Okay. So this is the relation MB और MA के बीच में, ठीक है. This is the mean speed of A. Mean speed of A can be made equals to mean speed of B. Okay. So now they are changing the temperature. They are saying दोनों की speed same हो जाए, मतलब यहाँ पे 8 RT by pi M A is equal to, let's say T1 is equals to 8 RT by MB हो जाए, ठीक है. ये कंडीशन है. तो पहले अगर कंपेयर करना है ये हटा दो, राइट. तो दिस इज T1 by MA is equal to T2 by MB. Now you can relate over here, MB की वैल्यू रख दो यहाँ पे, ठीक है. 3 pi by 8 MA. So this is T1 MA is equals to T2 3 pi MA और ये 8. So MA से MA कट. Now you are able to get this relationship. T1 is equals to what? ठीक है. So A is at a temperature T. अगर A का temperature T है, B का temperature T dash है, T should be greater than T dash. Okay. अब यहाँ से right you can say, so you can see जो T2 है, right, वो क्या होगा 3 into pi. 3 into pi की वैल्यू कितनी हो जाएगी 3 into 3.14 9.42 है ना. हो जाएगा 9.42 डिवाइड बाई 8. T1 is the temperature of A gas. So ये भी लिख सकते हैं यहाँ पे TB. So you can see कि temperature of TB is more at this point. ठीक है. So T dash should be more. It is not wrong. A is lower to a temperature T2 while V is at T. Okay. अगर B का temperature T है, तो temperature of A कितना हो जाएगा? Temperature of A is going to be 8 by 3 pi. यही हो जाएगा. A is nothing but 8 T2 by 3 pi, whatever T2 is nothing but T. T2 is nothing but T. B का temperature जो है, right, so do not get confused over here इस T2 से. ये अपना T2 क्या था? TB था. अगर TB T हो जाएगा तो ये क्या हो जाएगा 8 by 3 pi. 8 by 3 pi. So this is our answer. Both A and B. Okay, so okay, तो पहले क्या करना था, स्पीड से मास का रिलेशन निकाला हमने. We try to find कि ये कब इक्वल होंगे और इनमें टेम्परेचर में क्या रिलेशन होगा. Okay, that's it. Partial pressures are simply additive for ideal gas. Okay. Non-ideal gas such as ammonia or oxygen, we try to consider them as ideal gases. We should be good. Okay. Options हैं overestimate total pressure, underestimate total pressure, underestimate at P at low pressure. Okay. So they are relating with Z over here. Non-ideal gases के लिए low pressure में Z is less than 1 and high pressure में Z is greater than 1. We can say this is nothing but Z is nothing but V real by V ideal. Now we have to relate with pressure. तो दे आर सेइंग कि अगर ये आइडियल गैसेस जो हैं वो रियल गैस, सॉरी नॉन आइडियल गैसेस जो हैं रियल गैसेस हैं, वो आइडियल गैस की तरह बिहेव करने लग जाएंगी। तो आइडियल गैसेस की तरह बिहेव करने लग जाएंगी तो पी आर वी आर इज नथिंग बट पी आई वी आई हो जाएगा। ठीक है, मतलब वन वी वन इक्वल टू पी टू वी टू ऐसा, राइट। तो अब यहाँ पे अगर हमें वी आर बाई वी आइडियल निकालना है विच इज नथिंग बट पी आई बाई पी आर। ठीक है, अब देखो लो प्रेशर पे क्या है, ये वैल्यू एक से कम है, राइट, ये वैल्यू एक से कम है, राइट। इसका मतलब क्या है, जो प्रेशर ऑफ रियल होगा वो क्या होगा, आइडियल से ज्यादा होगा हमेशा। we are going to overestimate, we will be having more value of pressure at low low pressure। pi by pr जो है वो हाई प्रेशर पे ग्रेटर देन 1 है, आइडियल शुड बी ग्रेटर देन दैट पी रियल। मतलब जो पी रियल की वैल्यू होगी वो पी आइडियल से क्या होगी, कम होगी, अंडर एस्टिमेट प्रेशर है एट हाई प्रेशर। so this is your answer। okay, okay, more questions are there। A capillary tube of uniform diameter contains gas sample A and B separated by short column of mercury L mm of length। ठीक है, ends are sealed। ठीक है, तो कुछ ऐसा है, एक हॉरिजॉन्टल पोजीशन में ऐसे ट्यूब है, उसमें L लेंथ का मरकरी है और दो गैसेस हैं, लेंथ से उनकी लेंथ A और B है, ये दो गैसेस हैं। ठीक है, ये जो मरकरी है इसका प्रेशर तो डाउनवर्ड हॉरिजॉन्टल में mg लगेगा, तो ये क्या हो जाएगा, pv के बराबर हो जाएगा। A is equals to pv which is nothing but AMM and BMM in length, the common pressure। ठीक है, in vertical position the lengths become respectively A dash and B dash in vertical position, मतलब okay, so let's say we are going to put it like this। so let's say this is L और ये आपका मरकरी हो गया, इसके कारण नीचे की तरफ mg लगेगा, तो mg लगने के कारण प्रेशर चेंज हो जाएगा, राइट। और राइट, let's say this is B gas over here, this is A gas, it is going to be B dash, this is A dash। ठीक है, अच्छा यहाँ प्रेशर भी चेंज हो जाएगा, यहाँ पे लेट्स से प्रेशर E डैश है, यहाँ पे प्रेशर क्या हो जाएगा इस पॉइंट पे, है ना, प्रेशर ऑफ A गैस A dash will be equals to pressure of B gas B dash, which we are writing P dash, let's say P dash plus L mm of Mg, ये हो जाएगा पॉइंट ऑफ प्रेशर। ठीक है, तो इसमें क्या है ना, हम बॉयल्स लॉ लगा लें, नंबर ऑफ मोल सेम है, टेम्परेचर कंडीशन सेम है, so we can write P into B is equals to P dash into B dash। so P dash is nothing but PB by B dash, इक्वेशन 1। दूसरे वाले केस में यहाँ लगा लेते हैं P dash plus L into A dash is equals to P into A dash, बॉयल्स लॉ। दोनों के लिए लगा रहे हैं अलग अलग टाइम पे, इसके और इस कंडीशन में और इस कंडीशन में। ठीक है, तो बस अब यहाँ पे क्या करें, P dash की वैल्यू ये रखते हैं, ये टर्म P B by B dash प्लस L इज इक्वल्स टू, ये इधर चला गया और यहाँ A आएगा, A dash E into है ना वॉल्यूम, वॉल्यूम की जगह हमने A dash into एरिया ऑफ क्रॉस सेक्शन लिखा है, तो एरिया ऑफ क्रॉस सेक्शन तो कट जाएगा, तो लेंथ रह गई P into B by B dash plus L is equals to P into A by A dash। तो इन दोनों को एक साथ लिख लेते हैं, ये इधर गया या ये इसको इधर ले आए, L is equals to P into A by A dash minus B by B dash. इधर गया था P is equals to L upon A upon A dash minus B upon B dash. Okay, we have to see this option. So this is L actually. L. Okay. Okay. तो यहाँ मल्टीप्लाई में तो नहीं, डिवाइड में यहाँ पे राइट, यहाँ पे b माइनस बी डैश b अपॉन बी डैश माइनस a अपॉन a डैश आ रहा है, हमारा उल्टा आ रहा है. ओके, दिस कुड बी द रीजन यहाँ पे ये उल्टा है. लेट्स से दिस इज गोइंग टू बी लाइक दिस. इस ऑप्शन के हिसाब से ऐसा भी हो सकता है ना, b नीचे हो और a ऊपर हो, ये a डैश हो गया, ये l हो गया और ये b हो गया b डैश. जब हम ऐसा लिखेंगे तो ये इसी ऑप्शन में क्या हो जाएगा ना, उल्टा हो जाएगा. राइट लाइक दिस. फर्स्ट पहले हम लिखेंगे कि p इंटू dash into a dash is equals to p into a. So p dash is nothing but p a by a dash. फिर यहाँ पे क्या होगा, यहाँ पे अगर प्रेशर p dash है, ये p dash plus l हो जाएगा. p dash plus l into b dash is equals to, है ना, p into b. dash की वैल्यू लिख लेंगे p a by a dash plus l is equals to p b by b dash. l equals to क्या हो जाएगा, p b by b dash minus a by a dash, है ना, उल्टा आ गया ना. हाँ, a by a dash minus b by b dash आ गया, बस is equals to l divided by a by b dash minus a by a dash. Okay, this is done. For 10 minutes each at 0 degree Celsius, two identical holes, nitrogen and unknown gas, are leaked into a common vessel of 3 liter capacity. Okay, under identical condition. ये कोई कंटेनर है, इसमें दोनों आइडियल होल से दो गैसेस भेजी गई, एक N2 और एक अननोन गैस, लेट्स से X. Resulting pressure is 5.6 atm. ठीक है, and the mixture contains 0.5 moles of nitrogen in the molar mass. Okay, so now you know pressure, you know temperature, है ना, 273 Kelvin, you know volume 2 liter. We calculate total number of moles. So N total is nothing but into V, 3 into 5.6 divided by RT. 273 R is 22.4. So 4. 3 by 4 is 0.75. Total number of moles are 0.75. Moles of nitrogen is 0.5. Moles of unknown gas 0.75 minus 0.5, that is 0.2. These are number of moles of X unknown gas हो गए. ठीक है, molar mass of unknown gas is, ये molar mass पूछ रहे हैं, क्या करेंगे. तो now we are going to see this rate वाला part, rate of diffusion. R N2 by Rx क्या होगा, identical conditions है, right. तो यहाँ पे क्या हो जाएगा, ये अंडर रूट mx by mn2, which is nothing but how many moles it is over here, कितने अंदर यहाँ diffuse हुए, how many moles come out, है ना, बाहर से इधर, अंदर कितने की तरफ आए. Right. So that is nothing but moles of nitrogen is 0.5 divided by 0.25, है ना. यहीं से लीक होके यहाँ अंदर कितने मोल्स बाहर, मतलब किसी और कंटेनर के लिए ये बाहर जा रहा है, राइट. यहाँ से कितने मोल्स बाहर निकले, राइट, 0.5. जैसे कितने निकले 0.25, इनका रेशियो 1/2. स्क्वायर ले लेते हैं, mx 2/1, not 1/2, 2/1. mx by mn2 is nothing but 4/1. mx is nothing but 4 into 28, that is 112. So 112 gram per mole. Okay, that's your answer, B. Okay, so that's it. one and more than one, I will discuss in next, let's say, class. Okay, I hope you are able to understand all these solution.